Bam! Mr. Tarot. In this video, we are going to do two examples involving trigonometric proofs involving double angle identities. So what we're going to do is move this little guy out of the way and review what our double angles identities are before we take our two examples. So we're going to be changing this to a fountain pen. And remember that we have the sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta, and I'm giving you these identities without proof. And we're talking about changing the size of the angle measure that is inside of our trig function. So we have an angle that's twice as big in here for the sine of 2 theta than it is on the other side of this equation. So maybe this is like a 15 degrees, and this is 30 or 40 degrees, and this is 80 degrees, though, in our two problems today. And often when we work with double angle identities, we actually don't know the measure of the angle measures. We're more concerned about the ratios that we're getting out of these trig functions. We have also, besides the sine of 2 theta, which is equal to 2 cosine of theta times the cosine of theta, we have the tangent of 2 theta, which I'm giving to you just for information. I'm not going to be using this in these two examples today, but we have 2 times the tangent of theta over 1 minus tangent squared theta. And then we have the cosine of 2 theta, which is equal to the cosine squared of theta minus the sine squared theta. And this almost looks like the Pythagorean identity that says sine squared theta plus cosine squared theta is equal to 1. And if you just change that plus sign to a minus sign, then we have basically something totally different. Our answer is not just a simple constant, not a just 1, and we actually get a ratio that is the result of taking the cosine of an angle that is twice as big as the angle measure that we're using on the other side of this expression. Now, I argue that these are the three identities that you have to memorize, but there are two other versions for the cosine of 2 theta, and it's going to be cosine of 2 theta written in terms of just cosine of theta, or written into the terms of just sine of theta. And you can memorize those if you would like, but I honestly myself even find that rather difficult. So we're going to use and remember the Pythagorean identity that says that the sine squared theta plus cosine squared theta is equal to 1, to write our double angle for cosine of 2 theta in terms of only sine or in terms of only cosine. So first we're going to take a look at the cosine of 2 theta is equal to cosine squared theta minus, now what we're going to do is we're going to use that Pythagorean identity that I have written down there on the side and kind of move things around and say that sine squared theta, if we subtract both sides by the cosine squared theta, then we have sine squared theta is equal to 1 minus cosine squared theta. And, well, we're going to just do that substitution. And then we're going to, so we're taking out that sine squared, replacing it with 1 minus cosine squared. We're going to distribute that negative through the parentheses now and have that cosine squared theta minus 1 plus another cosine squared theta. And therefore we get the other version, or second version, for our cosine of 2 theta, which is 2 times the cosine squared theta minus 1. So we'll take out that scratch work, bring up our second version of this identity, and work on coming up with the third version of this double angle identity, which is cosine of 2 theta in terms of only sine. So now we're going to, again, we're going to be looking back at our sort of form of this double angle identity that we have memorized, if you will, and we're going to take out the cosine squared, and remembering that, again, with this Pythagorean identity, if we subtract both sides, I'm showing it as I'm just crossing it out, but if we subtract both sides by the sine squared theta, then we're going to have 1 minus sine squared. So cosine squared comes out, 1 minus sine squared goes in its place, minus, and that's with that substitution, minus the sine squared we had in our original form of the identity, and we have 1 minus 2 sine squared theta, ultimately giving us 3 versions for the cosine of 2 theta, that double angle identity. And if you remember all 3 of these versions, then you're going to get through a couple of homework problems that much faster. But if you want to just remember 3 double angle identities, sine of 2 theta, tangent of 2 theta, which you can derive as well if you so desire, and our cosine of 2 theta is equal to cosine squared minus sine squared, 2 cosine squared minus 1, and 1 minus 2 sine squared. And the fact that we have 3 choices for a double angle of cosine is going to add in a little bit of additional difficulty with these problems that involve the cosine of 2 theta. So our first example here, we have the sine of 2 theta over 1 minus cosine 2 theta is equal to the tangent of theta, and normally you want to start on the more complicated side. So we're going to do a little bit of better job of notation than I did when I made these original trig-proof videos many years ago, which I'll have a link in the description below. But we're going to say that we are officially or formally starting our proof, and let's just identify this with a different color. So we're going to be doing our proof. We're going to start on the side which we believe to be the more complicated side. In that case, it is the left-hand side, and simplify it down to the expression that has a lower degree, the lower number of terms, whatever you feel looks like the simplest. So we're going to start with the left-hand side, which is sine, not 2, but the sine of 2 theta over 1 plus cosine of 2 theta. Now, to start this proof, we don't have much choice. On the left-hand side, in the numerator, there is only one choice for the sine of 2 theta, and that is to do, it's not going to be very nice over there, not much room. We're going to only have one choice of saying the sine of 2 theta is equal to 2 times the sine of theta cosine of theta. And that is going to be over 1 plus, okay. Now look, remember, when you're doing trig proofs, you have the answers sitting there right in front of you. And the tangent of theta is, so if we're thinking about doing a proof that we've obviously started, but our final line needs to be the tangent, we could do that actually, we can move it around if we need to. Without, now that I'm not using a chalkboard, at least for this video, the tangent of theta, don't think I'll ever give up my chalkboards. The line above that needs to be the sine of theta over cosine of theta, so that we have that final right-hand side version of the tangent of theta. So we need to have the factor of 2, and really more importantly, as far as giving us direction, the factor of cosine of theta to cancel out. We need the factor of cosine of theta to cancel out of the numerator. Well, that means that we need to have a factor of cosine in the denominator. So it's probably not going to be a great idea to use this version of the double angle identity for the cotangent, or the cosine, excuse me, of 2 theta in the denominator, because I don't want to introduce a factor of sine of theta in the denominator. I want to introduce a factor of cosine of theta in the denominator that's going to allow this cosine of theta to cancel eventually. So we're going to do the substitution where we have 1 plus, and now we're going to take out, substitute out, or bring out the cosine of 2 theta and substitute in what it is equal to, which is 2 cosine squared theta minus 1, which either you've memorized or you have derived it for yourself as you do your homework, like I just showed you. Now, we're going to have this plus sign in front of the parentheses isn't really doing much, so we're going to be able to let the 1 minus 1 cancel out, giving us 2 sine theta cosine theta over 2 cosine squared theta. And now we can show that, not with the eraser, but when we can take these factors now and divide out these common factors, anything divided by itself is 1. Can't do this with terms, not with something that's added with something else. We have a cosine factor in the numerator. We have 2 cosine factors in the denominator, so we're going to let one of those cosine of thetas cancel out with one of these cosine of thetas. It's a little funny. Don't forget that the cosine squared theta is the same thing as the cosine of theta squared, or cosine of theta times the cosine of theta, and one of those factors are canceling with the factor of cosine of theta in the numerator. That is simplifying to give us, on the right-hand side now, the sine of theta over the sine of cosine of theta, and that, of course, we know is the tangent of theta. And that is the end of our proof, and your book might be giving you little QED, which is a little abbreviation here for a Latin expression, just simply saying that you are done with the proof. Bam! Okay. Now we're going to take a look at the second example that we have here. And this proof is going to be a little bit more involved. So let's see what we got here. We have some difficulty with this second example because we've got a double angle for cosine and a double angle for sine again. We always have a little bit of extra difficulty with that cosine of 2 theta because we have to we can really send ourselves down a long and difficult path if we choose the wrong of those 3 identities that we have for cosine of 2 theta. So let's see what happens. And keeping in mind that, again, we have that answer right in front of us, we know that we want our final answer to effectively be some form, or simplified down to be 1 over cosine of theta, allowing us to get a final answer of the secant of theta. So we want a denominator ultimately to just have a factor of cosine. All right. We're going to start on the left-hand side because clearly that is way more complicated than the right. So we're going to indicate that we're starting our proof. We're starting it on the left-hand side. We're not going to do any math initially, just copy it down. So the sine of 2 theta over the sine of theta minus the cosine of 2 theta over the cosine of theta. That is going to finding the common denominator because we want our final answer to be a single term. So we're going to multiply the left-hand side fraction by cosine of theta over cosine of theta. The right-hand fraction as multiplying that by sine of theta over sine of theta. Both of those, of course, just different versions of 1. So we have the cosine of theta times the sine of 2 theta minus the cosine of 2 theta times the sine of theta, and that is over our common denominator of the sine of theta cosine of theta. Well, with our first term here, we don't have any choice for the double angle of sine of 2 theta. That has to be basically substitution, and we need to do some kind of substitution because we need all of these angle measures to be the same size. We really can't, and our final answer here, or the end of our proof, is going to be a trig function of a single angle, not a double angle. So those double angles have to come out of here. And we don't, again, have a choice for the sine of 2 theta. We have the cosine of theta times 2 times the sine of theta cosine of theta. And I'm going to let the right-hand side just kind of sit here after the minus sign. Sine of theta times the cosine of 2 theta all over sine of theta cosine of theta. Okay, so we have multiplying here with our first term, 2 sine of theta cosine squared theta minus, I'm going to pause there for a moment, bring down the denominator, sine of theta cosine of theta. Now remember, our final answer needs to be secant theta, or a 1 over cosine of theta. We need to have this 1 over cosine show up. We need the sine function to cancel out of the denominator. And there may be multiple ways of doing this, but when I'm looking at it, I just see that we have this cosine of 2 theta over here, and I'm thinking about, well, we have a cosine squared showing up. And if I can remember that sine squared plus cosine squared is equal to 1, if I can have a sine squared come in on some other term, that maybe we can get rid of this squared second degree sort of factor, if you will, that cosine squared. If there was a sine squared to add with it, that would be replaced with 1, simplifying the numerator. We can look at this with a sine theta and replace cosine of 2 theta. Now, cosine of 2 theta can be 2 cosine squared minus 1, or 1 minus 2 sine squared theta. And do I want to bring in another cosine squared theta, or do I want to bring in a sine squared theta, hopefully to create an addition with that cosine squared theta? I want to bring in a sine squared theta. So the cosine of 2 theta is 1 minus 2 sine squared. And the great thing about proofs is you might be looking at this and seeing a completely different process, and we can still get to the same final solution. Now, distributing this factor of negative sine theta through the parentheses, we have got 2 sine theta cosine squared theta minus sine of theta plus 2 sine cubed theta all over sine theta cosine theta. Now, you might be looking at this and think we're going down a dark hole here, a path of no end, and have to erase some stuff and restart, but do not fear. That may very well happen with your proofs, but it may not. As I look at my first and third term, I have a factor of sine of theta here, and actually all of these have a sine of theta. I want to bring these two terms together and factor out a 2 sine theta out of just these two terms. You might try something different and still get to the end of our proof of 1 over cosine theta, which is equal to secant of theta. I'm going to see it this way. Now I'm just reordering my work around. Bring in the 2 sine cubed theta, which I miscopied, over with the first term, so that now I can bring out and factor out nice and cleanly the 2 sine of theta out of just the first two terms, giving us cosine squared theta plus sine squared theta minus sine theta all over sine of theta cosine of theta. We haven't got that denominator to simplify down just to have a factor of the cosine of theta yet, but that's okay. It's coming, hopefully, and if not, we'll just erase this and start over again, going at it at a different angle. We have the cosine squared theta plus sine squared theta. There is that Pythagorean theorem, and I'm crossing it out like it's really disappearing, but what I'm doing is I'm substituting. I'm going to take that expression out and replace it with just 1. So that's going to be 2 times the sine of theta. I'm going to show that multiplication of 1 just to really make sure everyone sees what I'm doing on YouTube. So 2 times sine of theta being then multiplied by 1, the substitution of that being equal to sine squared plus cosine squared is equal to 1, that Pythagorean identity, the first one, the one we use most often. Over, so we have 2 sine theta minus sine theta over the sine of theta cosine of theta. You should be getting excited. We are almost done. That is going to be sine of theta over sine of theta times cosine of theta. Then we're going to have our common factors of the sine of, need to turn off maybe that double tap feature of my pencil. So I don't keep bringing up the eraser. The sine of theta divided by sine of theta is equal to 1. Then that is going to give us a 1 over cosine theta, which of course we know that that is equal to the secant of theta, which is therefore the end of our proof. We are done. Bam! Which doesn't have quite the same hit as when I'm teaching live in front of a chalkboard. Of course, this is sort of live, but you don't see me. I'm just writing on my new iPad that I'm using for presentation in this strange simultaneous COVID coronavirus world. But there we have two proofs that involve double angle identities. I'm Mr. Tarrou. Bam! Go do your homework.